So welcome back. We have just performed an installation of Metasploit on Linux and then on Windows. And as you will have noticed, the installation is a little bit different. Windows was very simple, the executable install and everything is contained, whereas Linux is very much command line. But the overall effect is exactly the same. So let's move on and let's understand some of the key terminologies that we need to know that will sustain us and help us through the rest of this course. The first one is exploit. An exploit is the mechanism used to attack a system in a particular way that it was never intended to do. And this is key. If you think of the name Metasploit, it's kind of reminiscent of the word exploit. The idea here is an exploit is something in the operating system or the device, something that we can do that will make it vulnerable or do something it shouldn't do. So for example, in Windows, you can do a memory buffer overflow, which means that as we push something into it, it corrupts the memory, and then we can replace that with other things that we want it to do, some malicious code. So understanding what an exploit is, because when we run the commands in Metasploit, the first thing we will do is choose an exploit that we're going to throw at the target machine to try and break into. The second thing is a payload. A payload is a code that is delivered and executed using a framework on a target machine or device. This is the actual thing that we want to send to the other side. Is it some kind of virus perhaps? Is it just something that's going to exploit a specific application and then do something for us? But the payload is the compiled code elements that will be ran on that target machine. Then modules. Modules are very important to Metasploit. They're kind of part of the core framework. Modules within Metasploit are software components that perform chosen attacks on specified targets. So when we run the commands, we'll choose modules of things to run, and then when it hits the target machine, it breaks using the exploit, passes on the payload, and then the modules are the components that run. And then last but not least, a listener. A listener within Metasploit waits for incoming connections from targets that have been exploited. So the idea here is that you find the exploit, break the machine, you pass it your custom payload or code. The code then runs on the target machine and then connects back to your machine potentially, like a command and control type idea, and then sends information over specific ports, and your machine will pick up those and then be able to have a connection between those two targets. So, now that we've understood the basic terminology, those four, exploit, payload, modules, and listener, now we can go ahead and run some basic Metasploit commands inside to see how the syntax should work. So as you can see, we're back at the Windows Metasploit console. One of the first commands to know is the word banner. And you'll see that as you type the word banner, if we type it again, it keeps changing the banner that's being used and assigned to the Metasploit console. Now, of course, there's no specific reason for doing this, but it's just quite fun to flick backwards and forwards. Now, the next one is actually to type the word help. The word help, as it states, is really straightforward. It allows me to look at all the commands that I'm able to use, so things like quit or save or sessions, and then even down to database-specific application commands that are used for the Metasploit database itself. We also have the ability to connect, for example. So I can use connect, and let's say I connect to my blog URL, 443. This will make a connection to my home page of the site. It'll tell me that it's been connected. And the first thing it does, it'll take a bit of time to come through, but what it should do is go and grab, using a get command, and return the response back of what's come back in the retrieval process. So almost like a wget command does, where it goes and grabs the first page of something and then returns it. Now, of course, you can press Control-C, or if you're on a Mac, it'll be Command-C or whatever else, and that will stop that process. I don't want to wait for that to finish. We also have the flexibility of pinging, so all the standard commands come through, so I can go through and ping all the different bits and pieces. More importantly, we use the show command. The show command allows us to show whatever we would like to show. So I'm going to just say show exploits. And what this will do is it will now connect to the Metasploit database internally and start to grab a list of all the exploits that have been installed as part of the framework, and then it will list them all out in the screen. Now this can take a little bit of time to load because it has to compile this list, and then the list will get rendered out for you in the console. So we'll just give it a second or so, and there we go. And if we just scroll up and down, you can see we have everything from Windows. We can scroll further up. We have different services. We have everything to do with login. These are a list of all of the exploits that exist within Metasploit. Now what we could do is, remember, exploit was one of the first terminology words. So I could now type show payloads, and show payloads does the opposite. It goes and gets me the payload syntax that we can use. So this one, for example, here, if we take this one, is a VNC injection and gives me reverse TCP console. Now what we could do is we could decide, well, actually there's a specific type of exploit that I want to use. So you can use the word info, and then we could then type the exploit name. So if we were to scroll all the way back, I'll tell you the easiest way is actually just to go back and do show exploits. This will bring the list back, then we can pick the last one that's there, and then we can get info on that specific one that's there. We can do the same thing for a payload. So for example, this one here, we can run this one in info here, and we can click this. This will then load the details of that specific payload or exploit. So if we go back to our command here, it'll tell us exactly what it is, what platform, will it give us privileged access, who it was created by, but more importantly, what it will do is it will give us the parameters that need to be specified for usage of the exploit. So for example, our host is the target machine and the port that needs to be used for that one. So you can do exactly the same thing for any of the exploits. So for example, I could type in, let me get this right. I could type exploit. I could then do a Windows specific one. I could do an SMB, and if I do a 081 standard one, same thing appears. The syntax is very specific. You just have to browse through the path of exploit, etc., etc., etc. So now that we've got a list of those exploits available, we obviously need to know how to use those, and that's done using the use command. So I can actually go in and say exploit, the same one we just did, Windows, there we go, SMB, and then I can do the same one, MS08, and I can say use that exploit. Now notice what happens here. When we choose use, we then end up coming into MSF, exploit, and then in red, the actual one we're going to use. Now at this point, we can do show options, and this will give us the same information that we had previously, such as the parameters to use. Or what we can actually do is just type the word back, and the word back will take us directly to the MSF console itself. So we can flick backwards and forwards between various things. Now if I go back and choose use exploit again, then and if I do show options, oops, I can't type show options, there we go. So after typing show options, we're listed the various properties that we can set, the R host, the R port, and the SMB pipe for this specific exploit. However, what we don't have is the ability to set a payload, to be able to say what I would like to do is use this exploit, but then I would also like to use this specific payload instead. So this can be done by navigating kind of the same syntax, but we're going to use set payload, and then we get to type Windows, and I can type Meterpreter, and then I can do reverse TCP shell. Now if I just press enter on that one, and now if I do show options, what we get is we get a set of values for the actual exploit, which is our host and our port, and those are the target ends. So if this was going to be my Windows XP machine, The R host would be the IP address of that, and then the port would be 445. And then my machine, which would be this Windows machine, would then get the values of the L host and the L port. So that would tie the two ends together. So when you're looking at building kind of an exploit attack pattern, the logic is very straightforward. It's define the exploit, define the payload, and then tell it to exploit that machine. Once we'd configured everything, I would then be able to say exploit, and it would go off and start exploiting that machine. So as you can see, some basic syntax. It's really straightforward. It's really built around using the show command, the set command, and the use command, and then utilizing the info command for getting more information. As we go through the next modules and through the rest of the course, you'll obviously use different variations of this syntax to be able to perform the attacks on the target machines.
Okay, so here we are back at our Linux machine. I'm going to make sure that I boot up MSF console or Metasploit first. This should take a moment to load. What we'll also then do is launch another terminal, and in this one we'll actually navigate the structure using standard cd commands. So first off, I'm going to choose cd, opt, and Metasploit, and then we'll use the ls command to list out what exists in that structure. So when we did the base install, this is where the components went into. You'll see that we have various components. We have reset password, we have reconfigure scripts, we have create users. These are all commands that we can run. They're all shell commands. What we're going to do though is focus on going into the apps directory. And if I just list in here, you'll see we have a pro directory. And if I then list, you'll see that it's now broken even further. So in here, you can see that we have a data folder, we have modules, we have scripts, we have reports and plugins, but more importantly, we have the MSF3, which is where everything runs. So I'm going to choose MSF3 and then choose ls for list. Once again, we get a broke down structure. We've got config, data, db, modules, plugins. So let me just clear this back out. And then let's go into modules and we'll list this out. So when I access the modules, I can see auxiliary, encoders, exploits, NOPS, payloads, post. So if I go into exploits and then do ls again, you'll see we have that breakdown. So I'm going to go into C Windows and do ls again. And you'll see now that for Windows specifically, I'm able to find exploits for everything from antivirus to email, to proxy servers, to VPNs, to Telnet. And if I wanted to go and see what they were, I could actually go in and pick SMB, for example. And then I get the actual list of the exploits. And these are the Rails files, the .rb files that actually contain the code. So for example, if I choose nano and then choose PSExec.rb, this will then load me the source code, and you can see it's just standard code. It tells you what it's supposed to do, and you can trawl through. Most importantly, it gives you the references to the CVE issues, which if there's a website, CVE details, that you can go to, and then contains all of the code. Now, we're not going to make changes to this, so let me just come out of that. But that gives you an idea of how it's kind of structured. We have breakdowns of subdirectories, ultimately to get down to the Rails folders. Now, let me just go back through a couple. And what we'll do is we'll go to root, and then we'll go to the hidden MSF4 directory, and then I'll just clear it so we can see what's in there. So here we have the hidden directory, the .msf4. This is where we have modules, plugins, loot, logs. So if I go into logs and then list that out, we can see that we have the framework log, production log, and then we have session logs. So when we create a session, there's logs that get generated. If we were, as I mentioned before, if we had a connection, there we go. I previously did one where we were doing a downloading keylogger information, and this is where this generated my file. So if I go to Nano and just choose that file, you can see that there's a password in there, there's an account in there, and a domain admin group. So whatever was on that machine, I captured that information. And this information, it gets stored in the loot folder. And then of course, if I come back out, I can go into the modules folder, and you'll see there's nothing in those. I can also come back out and then go into plugins and list those out, and those are empty because these are the locations where you can define your own and they get added into the core Metasploit framework. Now, one of the things that's useful is having the ability to access core documentation for Metasploit. So what we can do is we can browse to the actual Metasploit framework directory, and what I'm able to do now is choose yard and doc. What this will do, this is now going to iterate through all of the Rails files and generate documentation so that we're then able to access that locally on our virtual machine. Okay, so it's now completed. As you can see, there are some errors. Some of the items didn't get documented, and that's purely based on the fact that using yard, not everything will get documented exactly as it should do. As you can see, some of the errors are about resolving links to information and understanding some of the text in those. But that gives us a pretty good setup of information. Now what we can do is, if we minimize our window here and our MSF console, and we can go into our directories, if we go into our file system and we navigate to that structure that we generated, so users share, and then go down to the Metasploit framework, and if we click in our doc folder, you'll see that everything that was generated is generated here, so all of our pages. You'll see that we can take the index.html, and I can just open with the browser, and the index.html page is obviously the home page or the first page of that documentation. So this should load any second. And there we have our documentation. So we can access this using just opening the HTML pages. But of course, that means I need to know all the links and how to get backs and forwards. So if we go back to our console application and go back to here where we've got users share Metasploit framework. And if I want to go ahead and use Python, I'll tell you what we'll do. We'll just clear this and put it up here. Python-m simple HTTP server. What this will do is this then sets up a website that listens on port 8000 inside that directory. So what I'm going to do here is remove all of this. HTTP 127.0.0.1/doc index.html. Oh, forgot the port on the end. Important. And there we have the documentation. So this is generated documentation using yard for everything that exists inside Metasploit. I'm actually able to click methods list, and if you leave that for a second, it should come back with the search option and allow me to start typing through the method list itself. I can look at the class list and the files list. So this means that I'm actually able to have a localized version of this on my machine. So if I just minimize that, you can see that everything that gets loaded is served up in our little simple HTTP server. So I'm going to close that down and I'll just clear that out. Now, of course, if we go to our actual Metasploit console, that window that we have open, what we can do here is, remember that we learned about using the use command. I can actually do exploit Windows SMB PSExec, and that's the location that we looked at in the regular window, which was Metasploit framework, modules, exploit, Windows, SMB, and then PSExec existed as one of those options that's there. So we're able to do a one-to-one mapping between the commands that we use in Metasploit and the structure within the Metasploit framework. Now, If we wanted to, we could actually utilize search, and I'm going to choose platform. And what we'll do is we'll look for Windows 7 SP1. And we'll specify the type as exploit. So I'm now telling it to do a search. It's going to build me a cache of all the information, but it's going to look for Windows 7 SP1 as the platform with a type of exploit. Now this can take a few minutes to run, it can take a few seconds, and there we go. This is everything that's Windows 7 related. Now if I wanted to change that and my target wasn't Windows, then what I could do is just change that and say, show me everything that's Ubuntu and is a type of exploit. Same process occurs, it builds the cache and will then return the values related to platform of Ubuntu with a type of exploit. And there we have them returned. Now we can change this. If I go in and remove the platform option, I could simply use type and choose payload. This will do the same thing as the exploit, but go and find me just the payloads that I'm able to look for. So using the search option, I'm able to find exploits, I'm able to find payloads or modules or whatever I'm trying to find. Remember that when we wrote the syntax help search, this allows me to use certain keywords. I've only used type and platform, but I could use something else. I could search by a CVE, an ID number, by going to cvedetails.com, looking for the exploit and finding the one that's there. As you see in the example, it says search CVE 2009 type exploit app client. So this is a quick way to be able to find the types of modules, exploits, payloads, whatever you're looking for, or even auxiliary services that are available. So here we are back at our Linux machine. I'm just going to launch Metasploit. And what I'm then going to do is just go back to a separate window where we can start to utilize some of the other commands. Now, one of the first commands that we want to utilize is something called rping. Now, when we look at rping, if we just type it, this gives us some usage. It gives us a host IP, an interface, and what type of MAC address is, and the count of packets that we wish to send. So what I'm able to do is use rping, and I can pick an IP address. So let's pick one of the IP addresses that's on my network, and I'm going to craft 5 specific packets. So I'll send these, it goes and hits my machine, and it should stop after 5 packets, and then comes back and tells me that the responses were great. So this is just like running a ping response, except we're using an ARP command to go across and check that that machine is still alive. Now, we could use something different. We could just target that one specific machine to keep it going endlessly. But really, this is the first kind of command that you would want to use to check the existence of targets. Once you have a set of IP addresses, you can then start going through the list and sending these requests. Now, that's all good and well, but actually, if we want to start crafting or scanning across ranges, then we're probably going to utilize something called fping. Fping is a command that will allow us to pass a set of IP addresses or a specific IP address. So if I just type fping, and I'm going to pass a couple of parameters here, I'm going to send 5 packets, and we'll use that same IP address again. Fping will then go ahead and send 5 requests to that machine, but just return a single response. This will give me it did 5 out of 5 and we didn't lose anything. Now, if I'd picked an IP address that was non-existent, I would have got 100% loss at that point. So it doesn't give us the output. It just simply says, bang, I've sent 5 values. Now, what about if we wanted to actually do a whole IP range, for example? So I'm going to go ahead and do the same thing. I'm going to send 1 packet this time, and then I'm going to use the G command and pass it a complete range. Say .1. Let's start at 70 and let's go to 100. Now what this will do is exactly the same, and here we go. We can see that the responses have come back, and you can see that these ones here on these specific IP addresses on the 80 range, they came back with 0% loss, which means that those machines are alive. But it also means that these ones that have 100% loss, that they're not valid. There's a couple of other ones that have come through. So this is a quick way to be able to say, you know what, I'm going to scan the entire subnet and I'm going to find the targets that might exist there. So let's just clear that back out. Now, once we have those list of IP addresses, then what we need to do is start to interrogate those machines. And that's where hping3 comes into play. So for example, we've gone through the process, we've found one of those IP addresses. So I'm going to choose that 192.168.1.70 address. And what I'm going to do is I'm just going to send a packet to that IP address. And it instantly goes in, and I told it to just send a packet to it, and it's crafted it as an ICMP packet. Just a single response. Bang, there we go. Now what about if I wanted to kind of trace route how it was getting to things? So I can use the same command, hping3. I can then try trace route. And then we're going to send to that same IP address. So as you can see, we're going to see some bouncing going backwards and forwards. It's gone out of Ethernet 0. It went out to the specific address. It's gone backwards and forwards, and I've told it to basically just endlessly send IP addresses as it's bouncing backwards and forwards using ICMP to perform the trace route to find that information. So let's just clear that one out again. Now I can change the syntax a little bit differently. Let's say that that IP address that I'm connecting to, I want to know if a specific port is available. So what I can then do is I can say, well, hping3 again, and this time I'm going to tell you to send a SYN packet, because that's the only way I can find out if a port is available. You can't use an ICMP or a ping to get to a port, so I'm going to use a SYN packet. And what I'm going to do is check and say, I want to see if port 80, obviously HTTP, is available. I want you to send it as if it came from port 4444, and then the IP address that I want to send that to. So this is now going to go and interrogate this IP address, look for a specific port, and when that machine looks at it, it's going to say, oh, hey, you've just come from a different random IP address, a different port, and it'll give me a response. So this has now gone ahead to that machine. It's now interrogating it, looking for that specific port. Now notice that no response comes back, and that's because that port is not open. If I just go back and retype that, and let's do that as 445, notice I now get a response back, an ACK response, because I happen to know that port 445, because this is a domain controller, is actually available. So we can instantly tell that when we send a packet request out, if there's no response, then the port is not available. But if I get an RST response back, then that's available. So it's actually a nice way to check the existence of ports. Now what we can do is, what about if ping is blocked? Because of course in some environments ping is blocked to the machines. So how do you kind of go ahead and try to see if something is available when ping is blocked? And that's where, let me just clear this. That's where I can use hping3 again. And this time what I can do is do an ACK scan. So I'm going to do one packet, and I'm going to use port 80 again. I'll tell it we're coming from the same port that we did the last time. And what I'll then do is use the same IP address. So this is going to go, looks very similar to the syntax we used before, but what this one's going to do is this one's going to go ahead and use a ACK scan instead of a ping to the port for that specific IP address. Now, of course, once again, we get a response back. It just comes back and says, hey, There's not really anything that's come back. Port 80 isn't open. There's 100% packet loss. Now notice that it didn't ping it. It just came back and sent a request and said, are you there? And it came back and said, nope. So one thing to remember is that sometimes, depending on the network infrastructure, an ACK scan can get blocked. Most firewalls will do this now. But in some environments, you'll be able to do exactly the same thing, send it to that packet, and you'll get an actual response. So let's just clear that down. Okay. Now, when we start to do major scans, then this is where we're going to utilize something called Nmap. And typing Nmap into the console will bring you a list of parameters as long as your arm. So we're not going to go through all of those. So what I'm going to do instead is type Nmap. And what I want to do is basically just do an ARP scan. An ARP scan to a full subnet, or at least a subset of the subnet. So I'm going to go in and use the parameters PR and SN 70, and then I'm going to stretch that out to, let's do that to 100. Now this will kick off Nmap. Nmap then starts at the 70 address and starts to go across the entire network. And there we go. So as you can see, it came back pretty quickly. If I scroll up and down, we can see that the host is up, the host is up. It brings back the machines that are available. Notice 70, there's no 71, 72, 73, 74, 75, no 76 or 77. So what it's actually done is it's narrowed down the list of IP addresses that are available. So of course, now we have that specific set. We could actually do that differently. So if I just press clear again, I can use Nmap. I used an ARP scan last time, but what I can actually do is use ping to do the response instead. So I'm going to use similar syntax. I'm going to use SN and then PE 192.168.1.70 all the way to 100, and then click enter. This time around, we're not using an ACK scan. We're using a ping response. So this is going to send a packet that's going to go across and ping, and there we come back with the results again. So it looks very similar. You have two different ways of doing it. The difference between using an ACK and a ping is really the amount of noise that you want to make on the network. That if you want to make lots of noise, then send ping packets across the network or start flooding the network with traffic trying to find the machines. Now, what you can do is you can actually target and say, well, what about if I wanted to perform the same thing? So we'll go with a standard scan, but this time I want to look for a specific port, and I'm going to use a UDP port of 53 on the subnet. So we'll do that same range again, 70 to 100, but this time when I use Nmap, it's not going to just find the machines that are alive. It's going to go and find the machines that have port 53 enabled. So we'll go ahead and leave that scanning. And there we have our information that's come back, and you'll see that lots of the machines have come back saying that 53 is open. Now if we clear that and we want to change the target slightly, let's go with that 445. So we'll go with UDP 445. And as you can see, you can change the syntax. You can go through and say, hey, I want to have this one, and it will say the host is available. If we go back, we can change this to any kind of port that we want to. Now what's lucky is all my machines are Windows machines, so they have some of these available anyway. So we're able to go through and scan by a specific port across a range. Now that's good and well. Those tools that I've showed you, which is rping, fping, hping3, and nmap, really are just tools to kind of use really before you get into Metasploit. So let's just minimize and go back to my Metasploit window, which will be here, and we'll full screen this. Now what we can do is, remember, let me just clear this so you can see it, and type search, and this time we'll type the word search scanner. Now in the last modules we did search exploits, search payloads, search auxiliary. What we're doing now is specifically looking for scanners which reside in the auxiliary container. And so it comes back with a whole list. You'll see we have an ARP scanner, We have a whole bunch of Windows login scanners. But what we can do is we could use a specific scanner. So I could say use auxiliary. I can then say scanner, and we'll do an SMB scanner, and we'll use SMB enum shares. So what this one's going to do, this allows me to connect and see shares. So if I do show options, which was a command that we hadn't looked at yet, when we have the ability to use an exploit or an auxiliary scanner or a payload, we have options available to us. So if I click show options, you'll see I have some settings, one of which is rhosts. Rhosts is the target address, the machine that we want to get to. Then it's going to ask us for some SMB credentials, which we'll just use an account on the domain that I have right now. And then we have some other parameters that will allow us to show files, spider shares, whatever it would be. Now, in order for us to set these values, we choose set. I'm going to choose set rhosts. We'll use that same IP address that we used before. So that now sets the rhost, which is the target machine, to that one. I'm going to set the domain to my Conesis Labs, which is the name of my domain. I'm going to set my SMB user to Loki, which is a user on the system. And then I'm going to set the password to the most secure password on the planet, pass@word1. So if I just now do show options again, you can see that we've completed those values. I have an rhost, I have a domain, I have a password, a username, and then some other parameters. And I'm going to leave everything else as it is. And then I'm simply going to type run. And this comes back and says the login failed. We didn't quite get a connection because it tried to go around on port 139, but then it hit 445 and then iterated through. So I was able to use a Metasploit scanner to hit my Windows machine using the credentials that I have, and it was able to list me the shares on that machine. And that's quite useful because that means that, and as I'm looking at target machines and trying to look for exploits, that if I can enumerate shares on a machine and it comes back and says, hey, it's Windows 2012 R2, now I need to look for an exploit of some description so that I'm able to utilize those shares that are available. What we'll now do is clear this out, and we'll actually flick over to the other console window. We'll remove the values from here that we had last time, and then we'll flick over to Wireshark. And obviously Wireshark is a network analyzing tool, but this allows us to set some specific values, and then we can log that information. So for example, you choose the specific port that you want to go out of. I'm going to choose start, and this is going to go ahead and capture all of my traffic. But what I can actually do is do some filtering that says Ethernet type. And actually what I want to do is I want to use a specific number that's going to look for ARP packets. So you can see that we've got an ARP request from here. So we have some requests going backwards and forwards. Who is that address? Who is that address? So now Wireshark is configured to just look for ARP requests. So if we flick back to our console here and we need to initiate an ARP request, what we can do is we can utilize one of the tools before. So we could use rping, and I'm just going to utilize one of the servers. So we'll do an rping, and we'll go back to here. And as you can see, instantly we have ARP packets going backwards and forwards. So we can see the broadcast is coming. We can see the question, who is 192.168.1.70, and tell me who that is, and 45 is me. So obviously we'll stop that going because that's going to send quite a few packets. So let me just clear that and go back. So you can see right here, the packets are gone backwards and forwards, and it says, who is it? Tell me. And then 192.168.1.70 returns the MAC address. So we can instantly target it to ARP values. Now what we can also do is actually, if I just remove that, it'll go back to checking everything. But I could choose UDP. I could then say, actually, what I'm looking for is anything that's UDP with a specific source IP address, which in this instance would be my IP address. So if my IP address as listed in here is 45, then anything that I send out which is a UDP request with an IP source address of me will get flagged up. Now I could also do the same thing. I could say TCP and do the same thing. Or what I could do is change it even further and choose destination, and actually the destination is 70. So I can say anytime a TCP packet is initiated and the destination is that, show it. Or what I could do is just remove and just say IP destination is this value, and anything that's leaving and going to that machine. So if I go back to here and I run my rping command, then notice the rping commands don't show up. So let's change the syntax that we're sending. So if I do ping and do a ping response, you'll see that now my ping responses come back. So be careful that the destination is only really valid depending on the types of content or the packets that you're sending. So we're able to clearly see the traffic going backwards and forwards. Let me kill my ping command and let me just clear that. So if we just clear those values down, you can see that it goes back to listing all of the values that are there. Now what's useful is the ability to go in and try various commands. So if I go through and do a SYN, or yes, a SYN one that we did earlier with hping3, I can actually go in and say, actually, I'm looking for port, let's do 443 because we know that responded. And my source port is 444 with my IP address of 170. And I can send that response. And then when I go over to here, you'll be able to see the traffic that's going backwards and forwards. So notice we can see it going backwards and forwards. Let me just stop that for a second. You can see that my values are going backwards and forwards. So this is the destination is 70 from me. I'm sending a TCP, a Microsoft one. It's going backwards and forwards, and you can see it's sending the values. And you can see it's the port 445. So coming to understand how to use Wireshark. Now, we're not going to spend lots of time understanding Wireshark, but it's important to know that when you run the various commands, whether it's auxiliary scanners in Metasploit or whether it's the specific tools, that the response and the implications on the traffic and what you get back are very important. So here we are back at my Linux machine. The first thing we'll do is type MSF Venom. MSF Venom is a specific tool that's now standalone. It used to be two tools within the Metasploit framework, which is called MSF Payload and MSF Encode, but they've been replaced now with MSF Venom. And this is a standalone application. I can just press enter here at a standard command prompt, and it will then list me out all of the values that are available to me. Now, obviously, it's important to understand those values, but I'm actually going to go straight through and just show you the basics of how to do this. So let me just clear this and type MSF Venom. And our first key is going to be the -P, which will be the payload that we wish to bring back when the executable is ran. So I've chosen Windows because this will ultimately generate an executable that I'm going to copy to a Windows machine. When I double click that executable, it's going to create something as a reverse connection to my listener that I will have on the Linux machine so that the two can be connected. So I'm choosing Windows and I want to have a Meterpreter session come back, and what I want to be able to do is just use reverse TCP. And that's my communication mechanism. I want to use Meterpreter and reverse TCP. My next command is E, which is to encode. So I want to encode what I'm doing, so it makes it a little bit more complicated for anything to know what my code is actually doing. So I'm going to use one of the default ones. Now you can go online to see others, but this is a standard one there to encode values. I'm then going to do the -I and then put 5. This is the number of iterations that I want to go through as far as the encoding would go. I would like this to run 5 times, encode it, and then encode it, and then encode it, and encode it, and encode it. You get the idea. What I'm then going to do is use the -B, and this is actually a kind of a list that says these are the bad characters that we wish to avoid. Now, I'm not going to spend too much time on this one, but I'm going to use a hexadecimal as a bad character that we don't wish to use. What I'm then going to do is type a parameter. Now, you'll notice I typed the word lhost. An lhost is one of the options that when we're utilizing an exploit in Metasploit, it's one of the properties. Or if I choose a payload. So if I choose payload of Windows Meterpreter reverse _ TCP, the first thing it asks me for is an lhost. The lhost being the hack machine. So this machine here. So I'm going to choose lhost equals and then my IP address of this machine, which is 172.16.1.38. I'm then also going to specify a port, and I'm going to choose SSL. So what I'm now doing in this command line is setting up some of the default properties within this executable. So what that means is that when the executable is double-clicked on the Windows machine, it's going to look for an IP address of 172.16.1.38 and try to make a connection over 443. What I'm then going to do is choose the -F, and the -F will allow me to specify the format of this file. And of course, I want to create an executable, and then I'm going to pipe that one out, and I'm going to call it payload.exe, and click enter. Now this will go ahead and use MSF Venom, wrap everything together, and output me a payload.executable. So there we have it. So what I should be able to do is just do ls. As you can see, my payload.exe is now available. So I now need to copy the payload.exe file to my other machine so that I am able to tie the two together. So I'm going to minimize my console. I'm going to open my computer, navigate to the share, which I have access to on one of my servers, and open up Payloads folder. What I'm also going to do is open a separate window, go to my home directory, and you'll see that my payload.exe file is available. I'm going to copy this, and I'm going to paste this over into my network machine. So let's just minimize that, and let me go back, this time to my Metasploit window. So I'm going to put this into full screen mode. So what we now have is we have an executable copied to a Windows share that will look at my network machine, this Linux machine here, and try to make a connection over 443. Now, in order for that to work, I need to tell my Linux machine that it needs to be listening for that. So I'm going to type the word use, and I'm going to use an exploit, and I'm going to use one called multi-handler. If I do show options, this is going to come back and say, well, there's not really anything that needs to be set because it's just going to sit there and listen. And I haven't told it to do anything yet. I haven't set a payload. So let me clear and let me type set payload. And remember what we chose in the executable that we generated. We chose Windows, Meterpreter, and we chose reverse TCP. So now we're doing a one-to-one mapping. Whatever we generate in the executable is what we generate here. So I'm now have said, use this multi-handler, tell it to use the same payload. I'm going to do show options. And now what we'll see is it's expecting a L host and a L port, which was the settings that we had before. So let me clear that again. I'm going to do set L host, and it will be 172.16.1.38, which is this machine. And then I'm going to also set my L port to 443, which is the port that we chose. And then what I'm going to do is simply just choose exploit. So now, as you can tell, my reverse handler is ready on my IP address, ready to listen to 443. Now, if I just hop across to my Windows machine, I can copy this executable to it and then run that exe file. So here we are on my Windows machine. I already have the share open to the payload file. I'm going to copy this locally. We'll just paste it to the desktop for now. And I'm simply going to double click my executable and we'll leave that going and I'll flick back to my other machine. And there we have, we're now back at the Linux machine and you can see that by double clicking the executable, I was able to get a connection from the other machine, which is on the same subnet, and it's coming from a specific port, but it's connecting on 443. Now, what can we do once we're here? Well, actually, this Meterpreter window is actually being ran from that machine. So I should be able to type ifconfig, and I'm able to get my IP address of that machine. I could then also go through and check the host name. I could see what other things were running, or I could run other auxiliary tools to do further investigation. In our previous example, we generated an executable using MSF Venom. We copied that to the other location. We had the executable ran, and at the same time, we created a reverse connection between the two so that I could then interrogate that other Windows machine. Now, that's all good and well, but of course, that means you need to have access or have somebody execute something on your behalf. And that doesn't always work. So Metasploit allows us to do all of that process in the same commands. So let me just clear the screen so we can start from scratch. So first off, we're going to specify an exploit, and it's one that we looked at before. So Windows, I'm going to choose SMB, and we're going to use the PSExec. Now you may recognize the name PSExec. It's exactly where it comes from. It actually has roots back into the PSExec tool that is in sysinternals. So I'm actually going to specify this one. And then I'm going to ask for show options. And of course, there's lots of options that are available. And of course, we have seen this before. So I'm going to go ahead and start populating the values. Remember that our host and our port are the target machine that we want to get to. So I'm going to clear my screen and then type set our host, which will be my end machine that I'm trying to get to. So 172.16.1.51. And I'm then also going to set a payload that I wish to use. And for this one, what I want it to do is simply just return me a command prompt, a Windows command prompt. I'm going to use reverse TCP. What I'm then going to do is set my L host, which of course is me, which is how it's going to come back. By now you will have gathered that that's what it takes. You need to be able to say, well, I'm the L host, this is my target, this is my communication endpoint. I'm going to leave the L port as the standard 444 because there's no firewalls as such here. And then what I'm going to do is I'm just going to do show options again. And you can see that we have all this information for the payload configured. And if I just scroll back up, we have the R host and the R port configured. And I just need to set my SMB domain, username, and password, which is what we've used before. So let me just clear this, do setMB domain, which is my Conesis Labs, set SMB user, which will go with our Loki user, set SMB password, remember the secure password that we have. So now we have everything connected. Now what I'm able to do at this point is ready to exploit. So now we'll just exploit, and what you'll see is it will go ahead and create a connection. It will authenticate using the account credential that we have. It will upload a payload in the form of an executable. It will then start that service. It will then delete everything out. It will have been encoded, and then it will come all the way back, and then look what we get. We get a Microsoft Windows command prompt. So I can type in hostname and it comes back and says my hostname is Magni, which is the name of my machine. I can type ipconfig. I can do a directory listing. I can do all the things that you would expect to do from a Windows command prompt. So that was exactly the same as the last one, except we didn't bring a Meterpreter shell back. We brought a Windows command shell back using the same thing. But this time, instead of generating the executable up front and then having to execute it, we just push the whole thing together using an exploit within Windows. First off, let's understand what pivoting is within Metasploit, or just in general. So let's imagine there's us on our machine with Metasploit, and then within a corporate environment, let's say there are some servers or devices that we're trying to gain access to. Those devices are connected to the network of 192.168.111. And then, of course, we have another network, which is the network we can see, which is 192.168.153. And then in between that is a machine that we'll refer to as proxy. Now, in the real world, this may be somebody's workstation. You may have done a phishing attack or compromised somebody's machine that just happens to be able to see both of those networks. And this is quite common. For example, if you're able to send someone a phishing attack, or they can access a website and download some malicious payload, then they will be able to see both sides, whereas you can't directly see the other side in the network. That machine in the middle is connected to everything. So you, as the Metasploit, the attack machine, have direct access to the target, but there's no direct access beyond that because you have to go through this middle tier. Now we can utilize this middle box to proxy requests. So if I'm trying to get to one of the servers on the other side, obviously I first need to know that they exist. But once I know this, we can use Metasploit to say, I would like you to do this, and it will go through the middle gateway box, the proxy, and send it off to the other devices that sit behind there. So for example, once we have a Meterpreter session to the compromised machine, we can run something called get_local_subnet. And what this will do is this will run on that compromised machine, looking for the local subnets that local machine has access to. So in reality, what should happen is when we run that command, it should not only just return us the 192.168.153, it will return us the 192.168.111 as well, because those are the local subnets that exist beyond what we can see. And that's what pivoting is. Pivoting is the ability to go from Metasploit to a compromised machine to something beyond that we don't directly have access to. Now, once we've done that, then of course we can start using other components. And this is where port forwarding comes in. Now, it may sound very straightforward, but in the realms of Metasploit and in the same scenario that we had before, what we're able to do is in our connected environment, we can forward traffic from the Metasploit machine to those non-visible targets using the box in the middle, using that relay machine. So I'm going to utilize the port 3389 that's remote desktop, and I'm going to say that whenever you see that port, I want you to route that traffic all the way through the relay box, go out to the machines on the other side, and then return the request so the two can meet in the middle. So that means I'm able to remote desktop to a machine that I don't actually have direct access to, as long as I'm port forwarding through the relay machine or the compromised target machine in the middle. And that's done using specific connections and also port forwarding rules, amongst a few other things. Finally, once we have this access all the way through, then really it comes down to token stealing and impersonation. Let's go back through the same scenario again. So we have our machine connected through the relay. Once we have a connection and we can go all the way through, then we can use Metasploit to load a module called incognito that will look at those machines or the machine that we wish to get to and list the current tokens. And these are the user tokens. So domain/administrator, it will have the user token for that one. Once we have that list, we're then able to steal the token, or we're then able to impersonate that user. So I can then go through and impersonate one of the accounts that reside on those machines, which means that my user account that I may be using already that doesn't really have access to anything is now impersonating the domain administrator, for example. Now, obviously, that's not that straightforward, but the logic still stands. I'm able to elevate my existing account to be something else so that I can then create an account on the domain. I can give it administration rights, which will give me a permanent backdoor into the infrastructure. So let's get straight to it. We'll use pivoting to run some remote commands. We'll look at port forwarding traffic, and then we'll look at stealing user tokens and impersonating so that we can elevate and be able to create the backdoor accounts. So here we are back on our Linux machine. We're already loaded directly into Metasploit. And the first thing that we need to do is to go and compromise that machine. So what I'm going to do is use exploit, Windows, SMB, and we'll use the PSExec one that we used before. This is going to drop us into the PSExec window. I'm going to set my payload to be Windows Meterpreter session, and we'll do a reverse TCP, which is what we used before. Now if I do show options, we get all the values that we need to fill in. Luckily, because we're using the same session that we used previously, these values are still set for us. So my R host is the Windows machine that we compromised before. I still have my regular account. And then of course, I've already set up my listener, which is me on my IP address to SSL. So what I can do from here, I'm just going to clear the screen. I can then simply do exploit. And now we have an exploit open. So we have a Meterpreter session, which is now on my target machine. Now we know that this one works because we used this in the previous module and examples. So I'm now directly connected to this middle Windows machine. So now what I want to do is I want to be able to run specific things and find things that are beyond my reach. So the first thing we're going to have to do is run a command on that machine. So we can use run get local subnets. Now remember where this is running. This is running on the compromised machine. So this then returns me two subnets, one that I know about, and then a second one that I didn't know about. I assumed there was something, but I had not yet received those IP addresses. So now we know that there's a 192.168.1 subnet that resides on the other side of my machine. So now what we're going to do is we're going to use a command called background. What background will do is return me back to a standard Metasploit screen, leaving my session to my machine already open. There we go. So it's backgrounded my session. If I ever want to see the sessions, I can type sessions and and it will list me any sessions that I may have active. And as you can see, I have an existing session from before called session 3, but our new one is session 4. So let me just clear that. What we're going to do here is we're going to add a specific route to that subnet that we know we can't see, and we're going to send it down the session that we have. So we created session 4. So this means that any traffic that I wish to get to 192.168.1. something is going to go through my Meterpreter session. So my route's been added. What I'm now able to do is now go back into my session and start to run some commands. So I can do sessions I to make sure it's still 4 and choose number 4. And then I get the interactive session back for number 4. What I can then do is run another tool called run ARP scanner, and I'll specify that IP range that we don't have any information on. All we know is that my target machine that I've compromised has access to that subnet. So let's run the ARP scanner remotely on this machine to tell me what's behind. As you can see, it's finished ARP scanning on that IP address range, and now there's a whole host of machines and servers that reside on the other side. Now, I don't have direct access to these machines, but my target machine does. So we can then utilize these machines. We can then utilize my target machine to now get to other machines. And that's the power of what's called pivoting. The idea of me sending packets, traffic, whatever you want to send commands from the attack machine through this middle tier to get to something else. So in our last example, we went through the process of using pivoting, and we were able to run an ARP scanner so that we could find IP addresses that exist on the other side of the target machine that we have compromised. One of those machines that we're going to use is 192.168.1.74, because now we're going to look at how port forwarding works in conjunction with a pivoting effect. So first off, what we need to do is go back and check our sessions. So we can do sessions I, and we'll go back into our session number 4. Now, as soon as we do this, we're now back onto that compromised machine that we already have access to. What I'm going to utilize now is a command called port forward, and I'm going to add a specific rule that says whenever we are listening, so the -L is the listening for 3389, we want to send port 3389 to the remote host 192.168.1.74. So now we've created a relay connection. So from my machine, I'm actually now able to launch a remote desktop session, and it should funnel it all the way through the Metasploit session to the machine that I don't actually have visibility of. So in order to do this, let's just background the session, because in order to run the tool rdesktop, I'm simply going to type rdesktop 192.168.1.74, and we'll click enter. And this should launch, and there we are. We now have a remote desktop session through a Meterpreter session to get to a machine. So of course, if I knew the password, I could then log in, I could connect as another user, but now I have a remote desktop session, I can then do other things with that. And we also know that this machine, by the very fact that we got a remote desktop session, it tells me that it's currently logged in as the domain administrator. So in our last examples, we looked at pivoting by connecting to the compromised machine, having it run an ARP scan attack so we could see the list of machines on the other side of the network. Then we added a route to allow anything for that subnet to go through the Metasploit session. Secondly, we then looked at port forwarding and actually added a forwarding rule for remote desktop so that I could launch it from my attack machine and have it hop all the way through to the other side. Now, the most important thing outside of that is really elevation and escalation of privileges. So let's go back to our sessions, and we have an active session. So we'll connect to that one session. So we're back at a Meterpreter shell, and we can run something called PS. And PS lists services, executables, anything that's running on the machine. But more importantly, if we look down here, it lists out the accounts that those things are running under. So what we can do is actually, what I can do is type get UID, and right now you can see that I'm actually NT authority and system. So I realistically don't have any permissions. But what I could do is I could do steal token, and then I could take the token ID, for example, of this one, 3040, and steal that token. Now this tells me that I'm now the Cohnesis lab administrator. So I now have the ability, now obviously I want to check this, so I can do get UID, and you'll see that now I've actually stolen the token of the administrator. So I could perform other things under the guise of that one. Now what I can also do is I could drop token, and if I now go back and say get UID, I'm now back to my NT authority. So we can flick between the two. So I can say, hey, I'm regular authority, now I'm administrator, now I'm back. So we have the ability to go backwards and forwards. Now, one of the tools that Metasploit has built in is actually called Incognito. So I'm going to load that extension. And what this allows me to do is actually do something called list tokens. And what this will do is this gives me a list of the delegation tokens and the impersonation tokens that are available. Importantly, you'll see that the administrator is a delegation token that's available. Now, what I'm able to do here is impersonate the token, and I can say Cognitius Lab / administrator, and I'm now going to impersonate that specific user. So now, just as we did with the steal tokens, I'm actually now impersonating that specific user account. Now, what I can do at this point is I can go through and run specific commands. I could execute something under the guise of that individual user. So one of the things that we can do is I can go ahead and execute a command, for example. I could launch a command window. So I could choose execute -F. I want to launch a command, so CMD. I'm going to pass some other parameters that we won't talk about in this module. This is then gone ahead to my target machine, brought me back a command line that we've done before. If I use the command who am I, you'll notice that I'm actually the domain administrator logged into that machine. So now I could do a whole bunch of different things. I could delete files, I could add local user accounts, I could do all kinds of different things, or even add users to the domain if I was on a domain controller. So here we are back at our Linux machine, and as you can see, we're loaded directly into Metasploit. So I'm just going to clear this so we can start typing at the top. And what I wanted to do was to go through the search command. Search, obviously, remember, allows us to go through and search for an exploit. So what I'm actually going to do is do name, type the word SharePoint, and then do -T exploit. And the reason I want to show you this is to show you the massive list that comes back when you actually use Metasploit to look for a specific thing that contains the word SharePoint as an exploit. As you can see, there is one result that comes back, and that relates to SharePoint 2007. So of course, if you do have SharePoint 2007, then by all means, you can utilize this one, which is about remote code execution. So that should make you think twice before trying to use some of the basic exploits against SharePoint, because there really isn't that many vulnerabilities that are available in the SharePoint framework, and that's a good thing. But that makes it very complicated when you need to understand for yourself and make sure for the business that your SharePoint application and servers are nice and secure. So this is where we think differently. We think, well, there's not any way of us using Metasploit to break into SharePoint, so let's look at the surrounding applications that SharePoint requires. So, as we understand, SharePoint requires Active Directory, or at least some authentication stack. It requires a database infrastructure, which is Microsoft SQL Server. It also would then require any number of services such as Office web app infrastructure, or it might require Exchange for email or an SMTP gateway. There could be a reverse proxy, a firewall. As you start to realize when you think of SharePoint, it's not just SharePoint as the install, it's a whole host of other applications that create the platform. So let's change Windows slightly and go back to a separate console. And for here, what we'll do to help us first is we'll utilize Nmap that we used before. And we'll do a standard scan. And remember, we're still going to utilize the existing sessions that we had before. So I'm on a different subnet and I want to scan 192.168.1.70 to 80. This will give me 10 IP address range to scan and look for targets that we can compromise. Okay, so we have some come back. you'll notice we have 70, 72, 73, 74, 75, and 80. So that's always a good sign when there's that many kind of close together, that it's either going to be workstations or it's going to be server infrastructure, because most server devices and most standard infrastructure, whether it's using DHCP or static addresses, tend to go in a logical sequence. So we have some machines that we can utilize. So let's pick one of them. Let's pick the 192.168.1.70. So I'm going to clear this, and I'm going to do another Nmap scan, and this time I'm going to just target that single IP address. And there we have it. Our results have returned. If we scroll up to the top of the results, you can see that we targeted 1.70. It's come back with the list of ports, tells me it has DNS. It has a whole host of RPC ports that are available. If we scroll down, it will tell us that it's Windows 2012. It'll tell us the name of the machine, which is called Loki. Tells me the version of Windows, so it's 2012 R2 data center. It tells me the fully qualified domain name, and if we keep going down, it gives me the trace route. It gives me all kinds of information about this machine. Now, if we scroll back up for a second, based on the number of ports that would be open and the types of ports, I can probably guess that this may be some kind of domain controller. So now we have an IP address. Now we need to see what we can do with it. So remember, we scanned the network, only 10 IP addresses, of course. We targeted one machine and found the information back from an Nmap scan. So let's just clear the results. And I'm going to go ahead and do MSF console. I'm going to do -L because I want to read some files in later and I want to use it in a different format. So I'm going to choose MSF console -L, and this should then load Metasploit. Okay, Metasploit is now loaded, so we'll click clear. So we're going to use our standard exploit that we've used previously, Windows SMB PSExec. We're then going to go through and set our values. So our host was the IP address that we just did the fingerprint for. I'm then going to set my payload. I want that to be a Windows. This time we'll use a shell, and we'll do reverse TCP. So this is going to return me a command prompt to my Linux machine. I'm going to set the L host. This is the returning machine. And then we'll set the L port to be an obscure port. It could be anything, but obviously we need to make sure nothing else is listening. I know that 4444 isn't being used by anything. And I'm then going to go ahead and set my SMB domain. Now we know that the domain is Kinesis Labs. And of course, in the previous modules, we use an account called Loki with a super secure password of passoutword1. So we have our remote host, 192.168.1.70. We have our returning listener, which is on this machine on port 4444. We specify the domain. We have a user account. Now let's go ahead and exploit. So I'm going to exploit. It's going to run against the machine. It's going to upload the executable, run the executable, remove it, and then return me a command prompt. So now that I have a command prompt, I should be able to run some basic commands. So the first command I'm going to do is just net user, and what we'll do is we'll try and create a _hacker account with the same password, passoutword1, and I'll do add. Okay, so that means that my Loki account has some level of access to the machine that I'm on, which is great. Now this doesn't always happen, but normally you can use service accounts. We could have brute forced the password, or you could have been given an account, or it could be your account that you're using to see if you have the ability to add something. So I've now added a -hacker account or _hacker account to this machine. What I'm able to then do is we'll do net local group. And what I'm going to try and do is add my user to the administrators group on that machine. So I've now successfully created a local account _hacker and added it to the local administrators group. Now that's great. I now have a session connected to a Windows machine as a local hacker, and I have a command prompt. Now that doesn't particularly help me too much. I've managed to create an account, but I don't have access to do other things in the domain, because really what I would like to do is make that account a member of the domain, make it a domain administrator account. That's really what we're talking about. We're talking about elevating the account. So I'm going to exit out of the command prompt. This will close the session down, and it should return me to my Metasploit window, and I will press clear. I will type clear. So we're back here. I'm now going to change the payload that I've used, and I'm going to this time bring back a Meterpreter session, and this time we'll use reverse HTTPS, which will bring us back a connection. If I now do show options, you'll see that everything is still specified. I haven't changed anything else. My remote host is still the same, and my listener is still the same here. So let me just clear the screen and come up to the top, and then just click exploit. We're now going to go ahead and connect to that machine again. It's going to upload as before, and now it's returned a Meterpreter session. So it's exactly the same process as we had before, but this time the reverse handler is coming over HTTPS. So it looks like it's browser traffic, which is even better. So when someone's checking the network, it just looks like HTTPS something. So now that I'm connected, I can then do what we did before and load incognito. And this will load me the extension that allows me to check for tokens. I'm going to type list tokens -u. This will then list me the tokens that are running. And as you can see on the machine that I'm connected to, I have the administrator. I also have what looks like the SharePoint farm service account. So I can now choose to kind of impersonate one of these accounts. So I'm going to choose impersonate token. And because the administrator account is there, I'm probably going to have more success with this one. So I'm going to say impersonate the Conesis Labs administrator. So this is going to now try to elevate my account access to that administrator. It now says successfully impersonated the user Conesis Labs administrator. So now that my session is currently running under this account, I now need to re-execute my command line shell because I want to have something in the context of that user. So kind of like when you go to a Windows machine and say run as, and then specify a different account. So to do that, I'm going to type the word execute -f to tells me that I want to run a command prompt, and then a couple of other parameters that we'll come back to, which tell it to load the window in the context of me and specify what I want to run. So I'm going to enter that command, and now my command prompt has been returned. So remember what just happened. We connected to the machine. We created a local account because we exploited the Windows machine. We then came back and changed the payload so it runs over HTTPS and this time returns a Meterpreter session. We then chose to load incognito to find the existing tokens that are on the machine. Then we impersonated the administrator and then told Meterpreter to go and get me the command shell or the command line prompt under the guise of that account. So my Windows command prompt is now running under as the administrator. And I can type who am I? And this will come back and say you are Conesis Labs /administrator. So now what I should be able to do is type net group domain admins, take my hacker account, add /domain. So now, under the guise of me being an elevated user within a Meterpreter session and being able to make myself an administrator, I can now take that existing account, the _hacker account I created earlier, and now add it to the domain admins group of the domain. So what does that look like on the Active Directory server. So here I am on the Active Directory server. I can click on users, and there you'll see my _hacker account exists. And if I open this, notice there's no values because we didn't pass any values. So it's just an empty account. But if I choose member of, you'll now see it's a domain user. It was a member of the local administrators group, and now it got elevated to a domain admins account. So let's go back to my Linux machine. So now we're back at this machine. We now need to look at some way of maintaining access or capturing other information, because it probably won't be long until someone notices that there's an _hacker account being added to the domain. If not, it's already been flagged up. So what we're going to do is quickly exit from the session. We're now back at the Meterpreter window. And what I'm then going to do is I'm going to exit out of the Meterpreter session. This will take us back to our PSExec, where I'll click clear. And then what I'm going to do is go back and reset the payload that we were using this time. And I'm going to go back to Windows, and I'm going to go back to a Meterpreter session, and this time I want to go back to a reverse TCP session. And you might wonder why I'm flicking between them. One, it's good practice, but it's also good practice to change the traffic that's going backwards and forwards. And I'm just going to reset and make sure that my L host is set to my IP address because I want this to work. And then we'll just exploit. So this will go ahead and connect to that machine again and bring me back the Meterpreter session. So I just wanted to make sure that nothing was changed, because sometimes when you set the payload, the L host value can be changed. So that's why we set it again. But we're now back at a Meterpreter session. What I can now do is use something called get system. And what get system will do is go ahead and try and get me as the system account so I can see who I am as the user. What I'm then able to do is type PS, and we used this last time. I'm able to now see the list of processes that are running on those machines. And really what I'm trying to look for is something like this, the administrator, because I'm no longer running in the guise of that account. Now I could go back and do token steal, or I could do incognito again, but what I wanted to do is do it differently. I want to come in and take one of these accounts and migrate it so it becomes me. So I'm going to take this account, which is explorer.exe, with an ID of 1628. And I'm going to use a command called migrate. And what that will do is it will migrate me, and I will become that. So I'm going to click migrate 1628. So now I'm in the context of that specific user when it completes. So what we've actually done is I've migrated my session into an existing administration session, so I can now run something. Now, of course, what I'm able to do now is I can run something in what's called post. So I can do Windows, and then I'll choose capture, and we'll do a key log recorder. So this is a post capturing key recorder. So this is now sitting here waiting for things to happen. Now what we're going to do is I'm just going to come out of full screen mode, go back to a previous window. I'm just going to clear that screen down. What I'm also going to do is I'm going to browse to my MSF directory. And remember that everything that comes back from the server is going to be listed in the loot directory. And you can see that we have some information that's in there. So let's leave that as it is, and we'll flick back to our Active Directory server. So here I am back at the Active Directory server. Jeez. So here we are back at the Active Directory server. I'm going to cancel that, And I'm going to pretend to be an administrator. So I have a new administrator, or I need to create a new SharePoint account. So I'm going to go ahead and right click on SharePoint and say new user. I'm going to call it sp_apppool2. I'm just going to create a test account. Click next. Give it the super secure password that we had before. Tell it to can't change the password and password never expires, and click finish. So I've now just created a new application pool. So I'm now going to flick back to my Linux machine. So here we are back at the machine. Let's go back to my Meterpreter session. Still going. Let's flick back to this one and type ls. Nothing's been updated so far. So what I'm going to do is I'm going to close this one to save the last few keystrokes. And then that stopped the keystroke sniffer. If we now flick back to my previous window and choose ls, you'll see that we actually have a file listed, and it's been there the whole time, the one that was listed for today's date. I can now choose nano, and we'll choose that file. And as you can see in that file, there was a keystroke log, which said I typed sp_, then I typed app0, then I went through and did a control to get rid of something, then I typed pass@word and pass@word. So the keylogger was able to grab something that I was doing. Now this is a quick way of keeping a backdoor, because people will go onto the Active Directory servers quite frequently. They'll move accounts around. Now imagine how much information would be in this file if it was a large corporate Active Directory where the administrators were moving accounts, creating accounts, changing passwords. We would very quickly get access to lots and lots of information. So in the last example, we actually attacked the Active Directory server, but now we're going to try something different, because attacking an Active Directory server can be really, really complicated, and there's normally lots of security and policies around that. But often in a SharePoint environment, SQL servers often get stood up and they are not configured correctly, or they're not secured appropriately. So we're going to take a look at the SQL server. Now, first off, we need to find the SQL servers. So we have our command prompt open again. So I'm going to go through and choose Nmap. And I'm going to perform a quick scan against the same environment that we used last time. And what this will do is go ahead and perform a scan across the network, looking for the machines. So as you can see, our list has come back, and we have more servers than before. We have the range that we used last time, but we're still going to focus on here, but we do have other servers that we could utilize. And what we'll do is we'll simply go to the next server and we'll try that one. So let me just clear this screen, and we'll continue to use Nmap, but this time what we'll do is we'll do a scan on the network, but we're going to look for the SQL port. Everybody in the world knows that SQL runs on 1433 and 1434. So what we're going to do is pick that one specific machine. So we're going to go with 72, that was the next one, and we'll run that scan. That comes back very, very quickly and says, okay, there's something there, UDP 1433, it's telling me that it's closed. That's a good sign. So let's try a different scan. Let's do Nmap, and this time we'll do a TCP scan. Same address, 72, and same port. So this time it comes back and it tells me that the TCP port is actually open. So that's correct, because the UDP port for SQL is not 1433. But it comes back, and not only does it do that, it comes back and says, hey, I think it's something to do with Windows. I'm not 100% sure, but it looks like it's 2012. Now, that's good to know. Now, we could do a standard Nmap scan like we did before to make sure that that's right. So let's see if Metasploit can help us do something. So let's clear the results down. So now let's launch Metasploit. Okay, so here we are. I'll just clear that screen so we have more space. And then what we'll do is we'll utilize an auxiliary scanner, and we'll actually look for the MS SQL, which pre-populates that for us, and we'll look for a MS SQL ping. So this auxiliary scanner, if we type show options, asks us for a password, a remote host, and then a username and a password. So what this is going to do is it's going to try and find the SQL Server. So I'm going to set my R host to be that machine 192.168.1.72, which was the IP address. And then, of course, I need to set a password that we want to use. So I could do set password, and that would allow me to set the value that I want to use. So we'll just use password for now. And then, of course, I'm then able to run that scanner. So I can do run. It goes ahead against the machine. It's not going to be able to authenticate, but what it does do is it comes back and says, hey, I found SQL Server. It is there. It's on 1433, and it's got the name of the server, which is called vor. So that's great. So that's now just confirmed that that's a SQL Server. Now, just to prove that, let's go back and change that to 70, which was the previous machine that we used, and then let's do run. And what this will do is come back and say there's nothing there. So we know for definite that 72 is a SQL Server. So let's go back and just clear the screen for a second. So now that we've utilized the ping and we know that it exists, our next step is to try and log into that server. So we're going to change the auxiliary scanner to be MS SQL login. And of course, the difficulty here is we obviously have to change some of the parameters. So obviously we're going to set the R host to be that server 192.168.1.72. And then what we can do is we can set the password that we want to use, but obviously we don't know the password. So what I can do instead is set a password file. And I actually have one at the root directory in the doc one, and it's called top25passwords.txt. And that's all I need to set because everything else is still set. So I have the R host, which is the SQL box I want to get to, and a list of passwords. I already have the username. If I wanted to, I could set a list of usernames if I wanted to. In fact, if I do show options, there's lots and lots of options that are available. You see I'm using pass file. I could use user pass file as a combination one. I could just use user file. So I can flick between them depending on what I'm trying to achieve. So let me just not exit, but let me just clear that. And I should be able to run that now. So as you can see, it goes backwards and forwards between them with my combination of SA and the passwords in the list. And yes, you can see the word baseball is in the top 25, as well as Mustang or Superman. But what's been successful is my pass at word 1. So I've now been successfully able to authenticate against my SQL Server. And notice that was a full list of accounts. I could have had 50 accounts, I could have had 1,000 accounts, and it would have attempted to brute force them. So now that I have a successful login, the next thing I want to do is actually have a look at the SQL Server. So let me just clear this list. We now know what the password is, pass at word 1. So now that we have the user account, we now need to change to use a different service. We're going to use auxiliary, an admin, an MS SQL enum, and then we're going to enumerate the server. So if I just do show options as before, we have a password, which we now know. So I can do set password, pass out word 1. We need to set the R host, which of course is 192.168.1.72. And we're ready to go. So I can now go ahead and run this one. And instantly, there was lots of information that went up and down the screen. So let's just scroll backwards and forwards. First thing we can see is the list of logins that are on the machine. So we can see that our SharePoint accounts exist there. If we scroll further up, we can see policies. We can also see locations of the physical files, the names of the databases. This basically enumerates everything that exists on that SQL Server. So now let's take it to the next level. So to begin with, we've done a ping, we've brute forced and got a login, we've enumerated the server. So let me just clear that. So what our next logical step would be is to move into auxiliary, admin, MS SQL, and exec. So we're now going to look at executing something that that machine can do, utilizing built-in procedures inside SQL Server. So let's do show options again. You'll see what it does is we have a command option, and the command option allows me to launch command.exe and echo out owned and generate an executable. Now what we could do is we could have that be anything. We just need to specify a password, the R host, and the port and the username. So I'm going to say set R host 192.168.1.72, same as we did before. I'm going to set my password to be the super secure pass out word 1. And we already have the username set to SA. But then more importantly, I need to set the command. And this is where we can be really creative. So what about if I was to use netsh firewall show state? Now think that through. I'm now getting it to launch a command line and use some other commands that the server knows. So now that we have that, let's choose run. This will go ahead and connect, and you'll see that now my status has come back. It tells me that my operational, my exceptional, it says some are disabled, some are enabled. The whole thing could be enabled. This doesn't make any difference to the firewall because we're not breaking firewall rules. And that's the interesting point. Even if the firewall is enabled, unless you've isolated it to specific IP addresses, then the firewall isn't going to stop me. Now, what I can do here is I can now go to the next level. What I can actually do is, I tell you what, if we just clear this and do set CMD, and I'm going to say netsh, we're going to go back to the firewall, and I'm going to choose set OP mode, which is the operational mode, to disable. So I'm now telling the SQL Server to turn off its own firewall. So let's do run. So this goes ahead, and you'll notice what it does is it says it's using, remember this, XP command shell? Remember that old school one that we were told to never use? Well, actually, when we use the Metasploit tools, we can get it to re-enable it, and then we can tell it to run commands. So this just came back and said it was successful. So let me just loop back through and choose state, and then we'll run this one again. And you would see that the operational mode, it could be disabled, it could be enabled. So now that we've disabled the firewall, what we can actually do is now change and use an exploit. So I can say use exploit, Windows, MS SQL, and we'll use MS SQL Payload. So this is a specific exploit designed for SQL Server. What I'm able to do now is if I do show options, this gives me the information. Which payload do we want to give? What's the password we want to use, etc. So I'm going to choose set password, pass out word 1. We'll then do set the R host 192.168.1.72. And then we need to create what we would like to have returned back. So we're going to set the payload, and we'll do a Windows, and we'll bring back a Meterpreter session. We'll do that over reverse TCP as before. We'll show options to make sure we've not missed anything. Actually, we did miss something. We missed the L host, which is me, 172.16.1.38. We're going to leave the port exactly as it is, and we'll just clear the screen again. just do a quick show options to make sure that we're ready. So what we have is the method is CMD. My password and our host and username are all here. And then the return mechanism is me. So let me just clear that. So now let's exploit that. And this is now using SQL Server to generate the exploit payload. You can see as it's called command stager. It's using SQL to create the command line executable and then to return back to us the Meterpreter shell using SQL Server. So I'm not actually attacking Windows as such. I'm getting SQL Server to attack itself and then in the process to send me back a Meterpreter session. So here I have a Meterpreter session, which now means that I'm able to then do whatever I want to do. If I wanted to do a run post Windows capture keylog like we did before, then I'm able to do that. But what we've just done is managed to break into the SQL Server. Now, of course, if we just flick to the SQL Server, and here we are on the SQL Server, you can now see that these are my databases. Obviously, SharePoint has a big stack of databases. But now that I have a Meterpreter session and I have access to all of the tools in Metasploit, I'm now a very dangerous man. I could have changed that and said, why don't you create me a command shell instead? And I could have got a Windows shell. Then I could have gone through the process of adding accounts. I could have gone through the process of interrogating these databases even further. So here we are back at our Linux machine running Metasploit. And if you remember, what we actually did is we ran an exploit, we ran a Windows, an SMB, and then a PSExec exploit. And that exploit utilizes the mechanism for sharing files, i.e. SMB. Now, of course, if you remember, if I do show options, what it requires is specifically a domain, a password, and a username, and then also a share, which in this case is admin $, which is a regular share on a Windows machine. So let's think that through for a moment. In the last examples, we used a specific account. So if we go through and set these parameters, so we'll set our host first to that machine, which was 192.168.1.70. That was our Active Directory machine. We'll then go through and set, as we did before, SMB domain to my Kinesis Labs. And then we'll use the SMB account that we have, remember, which was called Loki. And then we'll set the password, which is a super secure password, passoutword1. Now, of course, let's stop for a second. First issue, as you can tell, is the super secure password. So our number one rule is to make sure that our passwords are not passoutword or password or any number of those top 25 passwords that everybody has. Now let me just clear this so I can run the exploit from here. Now, of course, we did set our payload and we chose it a Windows, and we'll do a Meterpreter, and we'll do a reverse TCP. So let me just show options just to make sure that we have everything set. Obviously, the only missing piece here is the L host, which is this machine that we're actually running on. Our L host will be this machine, remember? 172.16.1.38. So let's clear that again, and then we'll run the exploit. So the exploit goes ahead, and it sends the stage, and then it connects and brings us back. Now notice in the example here, what it does is it first authenticates as that user Loki. It then creates the payload and uploads an executable, then runs the executable, deletes the executable, and then creates the session. So two key pieces that we need to resolve in order for that to not happen. The first piece is this, the authentication, and the second piece is the ability to run an executable. So let's flick to our Active Directory server. So here we are on the Active Directory server. Now, firstly, before we look at anything on the machine, the first place we need to look is within the firewall to make sure that our firewall services are running. And as you can see on the Active Directory, it's running on the guest, the private, and the domain. This should be rule number 1. But actually, let's go a little bit deeper. Sometimes what happens is in order to keep the firewall in place, we sometimes create rules to allow subnet traffic to go backwards and forwards. So for example, in my test environment here, I have a firewall rule that allows traffic to go backwards and forwards. If I actually look at the put protocols, it's basically any protocol. And if I look at the scope, it's any of my subnets that I need to have access to. So in actual fact, just because the firewall's on doesn't save the day at this point because of this firewall rule. So rule number 2, outside of all the standard stuff, is to go ahead and make sure there's no firewall rules that override and effectively make the firewall useful. Now, let's go back to that account in Active Directory. So let me have a quick look on here. Find Loki. Here's my account. Look at the properties for the account. So nothing particular is filled out. It's part of the domain. But if I look at member of, you'll see it's a domain user, but it's an administrator on this machine, or an administrator on any machine. So for example, this could be the SharePoint server that this account has been added as a local administrator. So in a SharePoint environment, for example, the farm account is added as a local administrator. If I'm able to figure out the password for the farm administrator, obviously I get access to the whole of SharePoint, but more importantly, I get a local administrator account. So if I was to remove this account from the administrators, so let me just do this now. So now my account is limited as a domain user. So this is about creating the least privilege account. I'm going to apply that and just close that. And then what we'll do, before we head back to test it, we can also go through and expand our group containers. So you'll see, for example, I have OUs that match to all my accounts. And what I can do is actually create group policies that would be associated to these to restrict the accounts from logging in. So if I go to Group Policy Editor, which is here, I've expanded my SharePoint accounts, right-clicked and said Create a GPO, and then I've clicked my GPO called SharePoint Security, and then I've actually added a GPO, which I'm in the process of doing. If we expand the policies, the Windows name, the security settings, and go to Local Policies, we can do User Right Assignment. From here, one of the first things I could do is deny logon locally. This would restrict my account from being able to do anything on that machine, and even if I was able to grab those permissions, I wouldn't actually be allowed to log in locally. Now that doesn't fix it for the farm administrator account, because obviously that account does need that access. But any of the other accounts purely just need log on as a service and log on as a batch job or something else. They don't need log on locally. So we can actually deny their ability to log in. So let's close that down and let's flick back to our Metasploit machine. Okay, so we're back here. Let me just exit that session and clear the screen and go back to show options. So what we have now is we have the same settings as before. We have our Cohesys lab account with the passout word 1. We have the same thing. Now let me just clear that and type exploit. Now notice instantly my exploit goes across. It does authenticate initially as a user because it's a member of the domain, but then I instantly get a status of access denied. So that can be the easiest and simplest way of blocking the Active Directory one, outside of making sure the firewall's on, make sure you have antivirus running, or group policies that would restrict that. That simple move of permissions will block this process from running. Now, of course, I could go even further, and on the Windows machine, I could run something like App Locker and control the executables that are actually allowed to run. In all fairness, if you do run antivirus on the machines, as soon as the payload tries to be uploaded, it will 99% of the time get captured unless we've done something special to change the signature of the executable. So that's the easiest way to protect yourself from the Active Directory exploit. Now let's take some time to go and look at how to block the SQL Server attack. So here we are back on our Metasploit machine. And if you remember correctly, what we did last time is we used an auxiliary scanner and it was a MS SQL ping. So let's take a look at the options for this one. If you remember correctly, it just requires a password and an R host, and then we can modify the settings as needed. So let's just set our R host to the SQL Server address, 1.72, and then we'll just set the password to be something random like password. Okay, let me just clear that so we can run it, and I'll click run. Now, of course, notice what happens. It instantly hits the box, it does a quick scan, and comes back and says the server name, the instance, the version, the TCP port, and everything else that it's using. Now, of course, remember we went through a whole series of using enum and login and those different things. Now, how do we stop this from happening? Because remember that when we used Nmap, Nmap also showed that 1433 was launched. So let's go from here to our SQL Server machine. So here we are on the SQL Server. First thing, as we did last time with the Active Directory server, let's go ahead and check our firewall. Oh, and here we can see, just like in a normal corporate environment, we actually have some discrepancies in the firewall. So we actually have the firewall switched off on the SQL Server versus enabling the firewall and then putting in rules to allow traffic to go backwards and forwards. And actually for SharePoint environments, this is actually quite common that the firewall is turned off on the SQL servers instead of going through the effort of enabling the rules that we need for the specific firewall ports to be open for SQL Server. Now we can enable this one, we'll just leave it as it is for now, but we can actually go back and say, hey, let's turn that on, and that would block the ability for us to upload or perhaps a ping response or any number of things. Nmap would hit the box and then just fail those responses back. Now let's go back and look at the services on the machine. So if I go to the services snap-in, and if we scroll down to SQL Server, you'll see that we have some services running. The main one is obviously the SQL Server, then we have analysis service, integration, and then we have something called SQL Browser. Now SQL Browser allows the SQL Server to be seen in the infrastructure. So let's just minimize that and we'll launch SQL Configuration Manager. Now when SQL Server is installed, let's say we're running SQL 2014, this service, the SQL Server Browser service, is actually set to manual or disabled by default in the install. However, what happens, sometimes monitoring software needs to be able to see the SQL servers on the network, so sometimes administrators enable this service. Now, if I just actually stop that service temporarily, and then what we'll do is we'll go back to the Linux machine. So here we are back on the Linux machine, and let's rerun our ping scan. Now notice what happened this time. It scanned the host, it was 100% complete, the auxiliary module completed, but nothing came back. So there was no response from the SQL Server. So right in the beginning, if we had enabled the firewall, we probably wouldn't have found 1433. However, it may have been open because when you install it, we probably would have enabled the SQL Server rules to allow 1433 and 1434 to go backwards and forwards. But then if we turn off the SQL Browser service, then my auxiliary scanner is not even able to connect and see that something is there. So when I run the Nmap scans and I get the IP addresses back and I plug these in one by one, I would skip over this because I don't see that that's even running. So let's go back to our SQL Server. So we're back on SQL Server again. So our first task was to enable the firewall, and then our second one was to disable the SQL Server Browser service. Then of course, if we go into SQL Server and right click and then do properties, then of course, one of the options that we have is to actually go through and change the security settings that have been set. So right now, for example, my environment is using SQL Server and Windows Authentication Mode. Windows Authentication Mode on its own tends to be a lot more secure because we don't have an SA account lying about, which means that some of those modules don't actually run because they're expecting an SA account to work. Of course, you can run it with SQL Server and have a different account, but that is rule number 3, is to go in, just like in the Active Directory, and any accounts that we don't need to use. So for example, take the SA account here. I can right click on it. I can go to properties, and then inside there, I'm able to go through and set various options. I can go to status and I can say disabled and then deny permissions. So I could go through and set other accounts that would be used. But the best rule of thumb here is to use Windows accounts instead of SQL Server accounts for authentication.